Hey guys, how's it going? So this is LeetCode problem number 1456, maximum number of vowels in a substring of given length. So LeetCode medium problem, it's part of the LeetCode 75 as well, so good if you're studying for an interview. So yeah, so given a string S and an integer K, return the maximum number of vowel letters in any substring of S with length K. Vowel letters in English are A, E, I, O, U. Okay. So basically, this is going to be the length of the substring is going to be this k value here. And so basically, as we go through our string, we're taking a substring of that length. So for our first substring, it'd be ABC, then it'd be BCI, then it'd be CII. And while we're doing this, we have to keep track of the amount of vowels in that substring. And basically, we're just going to return whichever substring has the most amount of vowels in it. So like here, um, since our substring length is 3, basically the maximum amount of vowels that we can return would be 3 as well, which we do here, since there's a substring with I, which are all vowels. Okay, so let's go ahead and get started. So basically the approach we're going to take here is sliding window. Anytime you're working with like a subarray or a substring in general, normally it's going to be a pretty common approach to take. So create calls vowel counter. Just gonna count the vowels that we go through. Our for loop, so for I in range, we'll go through K to start out. Then if basically if S of I ends up equaling A or C here, A I O and then U. And then we'll just take vowel counter plus equals 1. Okay. And then we need to keep a track of the maximum vowel counter, which is going to be let me use a different word. Let's use greatest. Basically this is going to be keep track of the most vowels that we have in a substring at a given point in time. So we're just going to go and set this equal to our vowel counter. All right. And then S. Here we can just copy this actually. C, Control V. Since we're doing basically the same operation here, there's not really much point in changing it. But same idea here. If the current index that we're on ends up equaling a vowel letter, we need to increment our vowel counter. So here's where it gets a little tricky is actually, well, I already have it copied. Basically here, what we need to do is though, is using our sliding window, we also have to consider that we're leaving a value behind, meaning that if we're leaving a vowel, we need to decrement our current vowel counter to make sure that's not including a vowel that's the last vowel that's not in our window. So, for example, if we have A, B, C, I, D, F, kind of like over here, basically what we're doing is our first window would be ABC. All right, then it's going to be B, C, I. So now we have to forget that A. Now it's going to be C, I. That's going to come I, which at this point would be the most amount of vowels that we can have in a substring because our K is equal to 3 or our substring length is equal to 3. But then let's say, obviously we still have to go through the rest of our program. Um, so let's say we're wanting to go, now we would go to IID. Well, we have to decrement from our vowel counter because we still have this vowel there. Technically, the value is 3, so we can't just keep on incrementing. We also have to think about what happens whenever we leave a vowel. We have to decrement at that point, which we're going to do here. So I minus K, minus K, minus K, minus K, minus K. And we would decrement. A common mistake that it's not common to see on this problem, I think, is for people to do I minus one. Because whenever you think, most people, you don't really think about checking like three or four values behind you, you normally just think about checking the element behind the current index that you're on. So you also have to make sure you do I minus k because you want to subtract, you know, from the standpoint of here, you need to subtract three values back because we're leaving this like value right here. So if I'm at and we're about to go to, say, ID, we need to think about removing this. We're not wanting to remove, this element right here once we're adding this D right here. We need to actually remove this element right here. So that's why we do I minus K. And then we're just gonna keep on comparing our our val counter and our greatest val counter. And we're just gonna set greatest val counter to whichever one's greater. Okay. And then just turn greatest val counter. Let's run it. Okay, submit it. Okay. Um, Not great runtime. Pretty good memory though. Um, but yeah, it's pretty simple solution. But yeah, basically a good, you know, good notice is whenever you're doing any kind of sliding window, whereas then you're taking a subarray and then you're comparing values in those subarrays, pretty much it's almost always going to be sliding window. And there's several ways you can do a sliding window. You can use just one singular for loop if you want to, but normally if you're dealing with like a substring or something, you need to use two. But yeah, thank you.